In this video, we're going to be looking at addition angle formula and justifying them. So I've got a diagram here. Consider the two right angle triangles joined as shown. So obviously we've got the blue one and the red one. The blue one making an angle of theta degrees to the horizontal. And then the red one, there's an angle of beta degrees to the blue triangle. Now the important thing to look at here is the geometry of the situation and look at how the angles, all the other angles are shown, have been justified. So where other angles of theta are going to occur and so on. So take a few minutes to look at that and think about what's going on there. Now we're going to break it down into individual triangles. So consider this triangle here, the triangle OBC. By using trigonometry and by defining the length of OC as 1, we're able to get a value for the lengths OB and BC. So we know that the sine of B is the opposite over hypotenuse. So it's going to be BC over 1, therefore BC is the sine of B, or sine of beta. And then similarly, cos of beta is OB over 1, so OB is equal to the cos of beta. So we now have the two lengths in terms of our trig ratios. Next, we're going to look at the triangle OAB. And by a similar argument, we can identify what the sides AB and OA are going to be. Now, don't forget, we know that OB, which we've already justified, has a length of cos of beta. So, by doing exactly what we did previously, we know that the sine of theta is opposite over hypotenuse, so it's AB over cos of beta. Therefore, the length of AB is sine theta times cos of beta. By a similar argument, cos of theta is going to be the length OA divided by cos beta. So OA is cos theta, cos beta. And we've got another important result. Now we're going to look at our third triangle. So this is the triangle OEC. Now, when you look at this, by the same argument, don't forget we know that OC has a length of 1. So the cos of theta plus beta, so the angle is theta plus beta now. So the cos of theta plus beta is OE over 1. So the length OE is actually equal to the cos of theta plus beta. Similarly, the sine of theta plus beta is the length EC over 1. So therefore EC is equal to the sine of theta plus beta. And finally, looking at our last triangle here, which is going to be important for the future results. Okay, so this is triangle BCD. And we know that the length BC is the sine of beta. So by exactly the same argument as before, we've got the cos of theta is opposite over hypotenuse. So CD over sine beta. So CD is cos theta sine beta. And the sine of theta is the length BD over sine beta. So BD is sine theta sine beta. Now we're going to start, just bring all those results together that we've got for the various lengths. Okay, and while I'm writing these out, have a think about how we might use these to justify what the length, what cos theta plus beta is going to equal, or what sine of theta plus beta is going to equal. And the trick is, look at the geometry of the situation, look at the lengths that we're going to be using. So we know the length from O to E can be calculated by working out the length from O to A and subtracting the length from A to E, which is the same as O to A take away the length from B to D. And we know that because when you look at the diagram, you can see that B to D is the same as the length E to A. So, substituting from the values from above, you find that the cos of theta plus beta is equal to cos theta, cos beta, minus sine theta, sine beta. Similarly, if we go from E to C, you can see that E to C is the length from D to E plus the length from C to D. Now that's the same as AB plus CD, because D to E and AB, if you look at the diagram, are the same. Substituting our values as we did before, we're going to find that sine of theta plus beta is equal to the sine of theta, cos of beta, plus the cos of theta, the sine of beta. So these are the results that we've just determined. Now, if beta was equal to negative gamma, we'd end up with the sine of theta minus gamma, replacing the beta with negative gamma, is equal to sine theta cos negative gamma plus cos theta sine negative gamma. Now it just happens that the cos of negative gamma is equal to the cos of gamma. It's a symmetric function. And the sine of negative gamma is equal to minus the sine of gamma. So therefore, substituting those values in, we find that the sine of theta minus gamma is equal to sine theta cos gamma minus cos theta sine gamma. Similarly, the cos of theta minus gamma is going to equal cos theta cos minus gamma minus sine theta sine of minus gamma. But using the above results, we get cos theta cos gamma plus sine theta sine gamma. So, in conclusion, we get some general results. We can say that the sine of A plus or minus B is equal to the sine of A cos of B plus or minus the cos of A sine of B, or the cos of A plus or minus B is equal to the cos of A times cos of B minus or plus the sine of A sine of B. Notice how those signs are a different way round in the second example, so that's quite important to follow.